Hey guys, and welcome back to another video. In this video, we will be talking about 1.9 transformations of functions. Alright, so let's get right into it. So the general form for a transformation, so let's say g of x is a transformation of the f of x. So the general form is the following. So these are all the possible transformations that f of x could have in order to get g of x. So let's just go through them one by one. So first, let's start with what k means. So k is a vertical translation, right? So vertical translations look like this. All right. So basically, if k is greater than 0, then you have a vertical translation up k units. And when k is less than 0, you have a vertical translation down k units. Right? All right. And then next, we have horizontal translations, which is what the h represents. Right? So horizontal translations is basically moving the graph from side to side like this. Okay? So similarly, when h is greater than 0, you have a horizontal translation to the right, h units. And then when h is less than 0, you have a horizontal translation left h units. Alright. Okay, good. So those are all your translations. And so next we have dilations. So you can have vertical dilations, which is what A represents, and horizontal dilation, which is what B represents. And basically it's compressing or stretching the graph as shown here. Alright, so when absolute value of A is greater than 1, we say that it's a vertical dilation or vertical stretch by a factor of A. And then when absolute value A is between 1 and 0, then we say it's a vertical compress by a factor of A. Okay. And similarly, for B, when it's greater than 1, it's a horizontal compress by a factor of 1 over B. And then when B is between 1 and 0, it's a horizontal stretch by a factor of 1 over B. Okay, so there's two main differences, right? So here, when we had A is greater than 1, it was a stretch, vertical stretch. And here, when B is greater than 1, it's a horizontal compress. But if you think about it, if you have a graph, let's say a parabola, and you're stretching it vertically, then you're basically stretching it like this, so the resulting graph would be more narrow. But that's the same thing as horizontally compressing it, right? Because if you have a graph and then you squish it horizontally, compressing it, you're also going to get a narrow graph. So that's why those two things are the same. And then when A and B are less than or between 0 and 1, vertical compress and horizontal stretch is the same thing, right? So if you take this and we vertically compress it, so like that, we're basically squishing it's going to flatten out like that. And then we horizontally stretch it, do it like that. So we're going to also get a similar shape. So that's why those two things are just the same, just different names based on like which direction it is. And then the second thing to note is that for horizontal dilations, It's always by a factor of 1 over b. It's always by a factor of the reciprocal. Okay, so just keep that in mind. Okay, good. And then last but not least, we have reflections. So reflections are basically like flipping it over one of the axes. So as you can see here, when A is negative, it reflects over the y-axis, but when B is negative, it actually reflects over the x-axis since it never crosses the y-axis, meaning it has to reflect over the x-axis. Okay, good. So basically, when A is less than 0, we have a reflection over the y-axis, or sorry, x-axis, and then when B is less than 0, we have a reflection over the y-axis. Okay. And yeah, that basically summarizes all the possible transformations that a function can have. Okay? Alright, so now let's do a couple of examples where we try to identify the reflections. Alright, so let's say we have g of x is equal to, let's see, x minus 3 squared plus 5, right? Okay, so what are all the transformations on this one? So we have a plus 5, so that means it's a vertical translation. We have a vertical translation up k units, which in this case is 5. And then what else do we have? Well, we have x minus 3, right? And it might be tempting to say this is a horizontal translation to the left 3 units because it's negative, but remember that in the original equation, it was already like x minus h, right? It was like this. It was already x minus h. So that means that 3, h is positive 3. So h is actually positive. So this is actually a horizontal translation to the right 3 units. Okay. So yeah, just don't get tripped up over that. Just remember, basically another way, like a little trick, is that if it's like negative 3, just like take the opposite of that. So take positive 3. And if it was like plus 3, then that means like negative. The h was negative 3, so just take the negative of that, right? But yeah, those are all the transformations on this because there's no like a or b, right? Those are just both 1. Alright, let's do another example. Let's say we had g of x is equal to negative 6x cubed minus 11, right? Just something random. So let's list all the transformations. So starting with translations, we have a vertical translation. So we have a vertical translation, and it's negative, so that means it's down, and 11 units. Okay. And then horizontal translations, nothing, right? Because we don't have x minus anything inside the power, so there's no horizontal translations. Then we move on to dilations. The negative 6 is outside of like the power, right? It's not in the power, so that means that it's a vertical dilation. So we have a vertical dilation, or even like within a dilation of the see if it's a stretched or compressed. So 6 absolute value. So like a in this case is equal to negative 6, right? And we said that it's absolute value of a. So absolute value of a in this case is just 6, and that's greater than 1. So that's going to be a vertical stretch. And then by a factor just a. By a factor of 6. Okay. And then what else do we have? Well, it's negative. So when a was negative, what did that mean? That means it was a reflection over the x-axis. So then we also have reflection over x-axis. Okay, and then those are all the transformations for g of x. Okay, good. Let's do one more. say we have g of x is equal to minus 3 times quantity of 2 times x plus 4, and then this whole thing is squared, let's say, and then minus 1. Alright, so here we have like every possible transformation for the most part. So again, starting with translations, we have a minus 1. We have a vertical translation down 1 unit. Next, we have another horizontal translation. We have a horizontal translation, and this is negative, right? Because x minus negative 4, so it's to the left. All right, and then moving on to dilations, we have a vertical dilation right here because we have a 3 out front, and 3, like absolute value negative 3, that's 3. Which bigger than 1, so we have a vertical stretch by a factor of 3. And then we also have a horizontal dilation, right? Because we have the 2 being multiplied inside. Okay, so we have a horizontal, and it's greater than 1, meaning it's a compressed, right? Because for horizontal, it's always opposite. So it's compressed by a factor, and then also remember that it's a reciprocal. So if it's b is equal to 2, it's by a factor of 1 over 2. By a factor of 1 over 2. All right. And then finally, we have the negative out front. So that's on A. So that means we have a reflection over the x-axis. All right. So yeah, that's like pretty much, that's like almost all the transformations that a function could have. The only one really missing is like a reflection over the y-axis, which would be possible if the 2 was negative. Now, important thing to keep in mind is that like here it was pretty easy to like see all the transformations because the 2 was factored out. But like if we rewrote this as g of x equals negative 3 times 2x plus 8 squared minus 1. Now like obviously you still have the horizontal compression, right? Because you still have the 2 there. But you also have to remember to like factor it out, because like now if you just take this at face value, it might seem as if you like had a horizontal translation like left 8 units because of that, but we know that it's to the left 4 units. So that's why whenever like you're doing the transformations, you should always have your coefficient of x be 1. So like in this case, you can factor out a 2, so you just get this. So whenever you're doing transformations, always get like that coefficient of x equal to 1 first, whether it's by like factoring or something, and then do your transformations from that newly written function. Okay? But other than that, that's pretty much it for transformations of functions. If this video helped you, please make sure to subscribe so you don't miss any future videos. And I'll see you guys in the next video.